So what we're going to go through in this video right here is how to determine the probability of finding an electron in a 2D particle in a box model, right, where the particle in a box model is essentially a square, right? So the x and the y directions are equal to each other. And so what we're looking at is when nx is equal to 1, right, the principal quantum number of the x direction is equal to 1, and then ny is equal to 2. And we're looking at the region, right, where we're looking for it is from, essentially 0 to L over 2 in both the x and the y directions in those cases. So one way that we can approach this is we can just simply, plot out the wave function. And so if we write out what the wave function is for a 2D particle in a box, right, it's nx and y, right? So what we have is first the x direction component, right? So that's going to be the square root of 2 over Lx times the sine of nx times pi times x over Lx, right? And so nx is just simply the principal quantum number in the x direction, x is the position in the x direction, and Lx is the length in the x direction. And so that's going to be multiplied then by the square root of 2 over Ly, right? And that's multiplied by the sine of ny times pi times y over Ly. And right, so basically, right, it's the two different 1D particle in a box parts, right? You're just simply multiplying the two of them together. And so if we were to plot this for ourselves, right, so we'd have a square in this case, right? And so we're looking at the nx equals 1 and y equals 2 state in this case. So what we can easily see then is that in the x direction, right, we're going to have 0 nodes because nx is equal to 1. In the ny direction, we're going to have 1 node. And so we're going to have 1 node, then that's going to be exactly at the midway point, right at the L over 2 point, right? So this is simply L, this is 0. And so if we were to draw out, right, in a topographical map fashion, what it would look like, right, we would have, a hill on one side and a valley on the other. Right, and so what we're looking at in this case right here is the L over 2 region in both parts, right? So L over 2 would be right here then for the x direction, and then we have L over 2 right here. So what we're looking at is this space right here, right, that I'm kind of shading in. And one thing you can kind of already notice is that I kind of messed up drawing this stuff, right? I didn't do a perfect job, but you can see that, just by eye, that we're only really looking at a quarter of the area of the box. And so then we would only expect to find that electron a quarter of the time, right? 25% of the time. So, optically, we can just already tell, right, that's going to be a quarter of the time the electron can be found in that space, right? So 25%. Now, we can also apply, calculus, and we can do this, right? We can integrate the probability of finding the wave function, right? So if we, find the probability, which is just simply squaring the wave function. So if we square the wave function, so square nx and y, right, what we get is 2 over Lx times sine times nx pi x over Lx, right? And then the sine is squared times 2 over Ly times the sine squared of ny pi y over Ly in those cases. So what we can do, right, is just simply integrate it for both those different dimensions, right, for both the x and the y in those cases. And one thing we can also do really easily for ourselves, because both Lx and Ly are equal to each other, I'm just going to simply write them down as L for right now. But that shouldn't be too much of a problem. And so one thing that I'm kind of just going to want to jump in ahead of time too is if you've watched the 1D probability videos that I've done, in the cases, right, where L is equal to 0, that whole term is equal to 0, right? So you can completely ignore that part right there. And that's what I'm going to do right here, right? I'm not even going to include that step in calculating out the integration of it, right? I'm just going to leave that out and only pay attention to the L over 2 portion. And so, right, so if we integrate it, what we get then is 2 over L times L over 2 minus L times the sine. Actually, you know what? I'm just going to keep, I think for clarity's sake, I'm just going to actually just leave the x's in there, right? So we have Lx, L sine times 2 pi times here, you know what, let me just let me just take a moment. I know I'm messing this up, but whatever. Right, so what we have, right, for integrated, and I just write out what the equations, right, is 2 over L times x over 2 minus L times the sine of 2 pi n x over L over 4 pi n, right, times, right, and this is Lx, this is Lx, this is Lx, 2 over Ly times y over 2 minus Ly times sine of 2 pi n y times y over Ly over 4 pi ny. In those cases, right, so that's, you know, what we have right there, right? And if we weren't going from 0 to L over 2, right, if we were going from a different number, right, you would also then have to include, you know, subtract out the parts of it for the other thing, right? Because you're going, you know, when you integrate, you have, you know, your boundary conditions of the two different sides. So let me just plug in then the values that we have for x and y and for nx and ny. So we have then 2 over Lx times, right, x in this case is going to be L over 2 minus Lx times sine of 2 pi times 1, right, because nx is equal to 1 times x, which is L over 2 over Lx over 4 pi 1. And then that's going to then be multiplied by 2 times L over y times L over 2, right? Because y is equal to L over 2 as well, minus Ly times the sine of 2 times pi times 2, right? Because ny is equal to 2 times L over 2 over Ly, right? That's x and that's y. I keep forgetting to include those, right? So 4 pi n, and then we don't have the ny, right? We know what the number is, right? It's 2 in this case. So we have all of that. So we can work our way through it. And so we still have the 2 over Lx times L over 4 minus, and so now what we're looking at here, right, the Lx and the Lx cancel out. And so then the 2 and the 2 cancels out, right? So we have the sine of pi. Sine of pi we know is equal to 0. And so this whole thing is equal to 0, so we can disregard that. Over here, right, so minus 0 times 2 over Ly times, right, and so we have Ly over 2 right here, so we still have Ly over 4 minus, right, and so if we look at right here, right, we have Ly and Ly cancel out, right, the 2 and the 2 cancel out, and then sine of 2 pi is going to be equal to 0. So this whole thing comes out to being 0 as well, so we can disregard that. So that's a 0. And so as an easy way, right, looking at it now, we have 2 over Lx times Lx over 4 times 2 over Ly times Ly over 4. So the Lx's cancel, the Ly's cancel. And so we have 2 times 2, so that's 4, over 4 times 4, right, which is 16, which if we simplify down, comes out to being 1/4, right, which is 25% of the time. And so that's how you mathematically, you know, using calculus, are able to calculate what the probability of finding an electron in that region is for a 2D particle in a box.